All right, on what interval is f decreasing? I'm to part D now. Now decreasing, remember f is this function here. It's going to start decreasing here at 0, and you can see as x is getting larger, y is getting smaller. So this is going to start at 0, and we're going to end all the way over here, which is at 1, 2, 3, 4. Remember, increase, decreasing, we don't include the endpoints. State the domain and range of f. So f, the domain, is going to be from way back here, that's negative 1, 2, 3, 4, negative 4. And we are going to include the endpoints in this one. And here we're going to include positive 4. The range, that's up and down. We're starting way down here at negative 1, 2, negative 2. And we're topping out way up here at 3, it looks like. All right, let's move on to the domain and range of G now. That's down here. G is the blue one here. So way back here, we're back at negative 1, 2, 3, 4, negative 4. We're going all the way to here, which is a positive 3. In the range, we're going to have to estimate for this one. It looks like we're bottoming out here. I'm going to say that's at about a positive 0.3. And it's going all the way up to here, which is at 2, 3, 4. So there we are. Number 3. So this one I'm going to have to maybe use a separate piece of scratch paper for some of these. All right, so we're going to find f of 3. F of 3 means that we're going to replace each of these x values with a 3. Nine times 4 is 36. Those cancel out. And let's do f of negative 3 over here. Let's make this one here. Be careful here. Now, this gets a little tricky. When I square negative, that becomes positive. This becomes plus 3. And I have 36 plus 6 is 42. F of a, I'm going to come back over here. That's easy. That's just 4a squared minus a plus 3. Done. F of negative a can get a little confusing. Again, be careful with these negatives. And be careful with that, not that minus there. There we are. All right, next up we have f of a plus 1. So I'm not even going to try to follow these anymore. F of a plus 1. Now that might look a little weird, and it is. I'm going to FOIL that out. Make sure you don't distribute the squared. That's not a squared plus 1 squared. That's not what that is. You have to actually FOIL that out. And let's put that back together. So 4a squared plus 8a plus 4 plus a plus 4. And I'm going to combine it by like terms. There we are. That's f of a plus 1. Let's see if I can carve out a place here for 2 f of a. Well, that just says takes the original function and multiply the whole thing by 2 and replace all of the x's with a's. There we are. Not to be outdone, we now have f of 2a. This means I'm going to replace all these x's here with 2a's. Now, an easy place where students often miss this is they forget to square the 2. So this square is going to go for the 2 and the a. Which gives us 16a squared minus 2a plus 3. All right, next up is f of a squared. So this is going to give us 4a squared squared minus a squared plus 3, which is 4a to the 4th minus a squared plus 3. All right, I have 2 more to do, and I'm going to go to a separate piece of paper for that. So we're going to find f of a squared. Now, what this is saying is we're supposed to take 4x squared minus x plus 3 and square it. This is going to get messy. So let me scooch the paper up a little bit. And I'm going to show you sort of a newer, fancy way of doing this, a way that might actually look a little familiar to you. Okay, so I'm going to write it out twice. And I'm going to multiply it like it's a 3-digit number. 3 times 3 is 9. 3 times negative x is negative 3x. 3 times 4x squared is 12x squared. Put down my placeholder. Start again. Negative x times 3 is negative 3x. Negative x times negative x is a positive x squared. Negative x times 4x squared is negative 4x to the 3rd. Put down 2 placeholders. Start again. 4x squared times 3 is 12x squared. 4x squared times negative x is negative 4x cubed. And 4x squared times 4x squared is 16x to the 4th. And you'll notice all the digits line up, all the like terms. And now I'm going to add them up. Adding those up, I get 25. And there it is. Now, you may know another way to multiply 2 polynomials like that, which is totally fine. Nothing wrong with that. Use your way. Just make sure that it works. All right, the last one on this list is the f of x plus h. I'm going to also continue that on this sheet of paper. All right, so this is going to be 4x plus h. Wait, I think it was a plus h. It is a plus h, my bad. Squared minus a plus h plus 3. By the way, this is the beginning of calculus. This is one of the things that we're going to have to do, and we'll do more on that in this video. And it can, sometimes it's an x, sometimes it's a specific number like an a. I'm going to go ahead and FOIL that. Distribute the negative 1 there. And I'm going to distribute the 4. And all of that is that. That's a lot. All right. So we finally finished number 3. And here's this, what I told you is the calculus thing that's coming up. This is called the difference quotient. You're going to use it a good amount at the beginning of once we actually start calculus. So we want to get kind of good at this. Now, this one's going to get extra messy as well. So what I want to do is have us recall. Let me start here, and I'm going to use the back of another sheet of paper. So the tricky one is the f of a plus h. So that's going to be f of a plus h is going to be a negative to the 3rd power. So I'm going to use my scratch paper to multiply that out. So I'm going to start with, so this is what we're doing. I'm going to start with a plus h squared and now I'm going to multiply that times another a plus h, and then at the end, I'm going to distribute the negative. So I'm going to take a squared plus 2ah plus h squared and multiply that by another a plus h cubed. I'm going to do that multiply thing again. This gives me 2ah squared. And this gives me a squared h. Put down my placeholder. Ah squared, 2a squared h, and a cubed. Okay, so now we have that. So let's now do, oh, and then the negative version of this is going to be negative a cubed minus 3a squared h minus 3ah squared plus h cubed. Minus, they're all minus. Okay, so let's go back to here. Which is what the original problem is asking for, right here. So minus negative a cubed. Now, believe it or not, our goal is we want to set h equal to 0, but you can see we can't do that because I'll be dividing by 0. So I'm hoping to get rid of that somehow. And we will see that happen right now. So I want to point out that a cubed, negative a cubed, plus, that's a plus a cubed. These are gone. So we are left with this here. And I am now going to factor out an h from up top. Once again, you'll notice these h's reduce out. And we are left with and this was number 4. This is number 4. There you have it. A lot of work for that one. So let's see what we have for number 5. Evaluate the difference quotient for the given function. Now, this is a difference quotient. There's 2 forms of it. There's this form, this form. This is going to prove to be a little bit more useful, in my opinion, later in the semester. So let's try to do this. This is saying take this function minus f of 1. Now, when I put 1 in there, do you see f of 1 is going to give me 1 plus 9 over 4, 1 plus 4, which is 10 over 5, which is 2. And now what I'm going to do is to simplify, because they ask us to simplify. We don't like fractions instead of fractions if we don't have to. So I'm going to multiply both the top and the bottom by x plus 4. When I multiply these, they cancel. So I'm left with x plus 9 minus 2 times x plus 4. And down below, I have that. Now we have a good amount of cleaning up to do here. So I'm going to bring it way over here. And combining my like terms, I'm going to end up with 1 minus x. Right? 9 minus 8 is 1. X minus 2x is just negative x. And I'm not quite done. I'm going to notice that if I factor a negative 1 out of that, that'll switch these. It'll make the x positive and the 1 negative. That allows me to reduce this here. There you have it. All right, so that was number 5. Here we have number 6. We're looking for the domain of h of x equals 1 over the 4th root of x squared minus 7x. Well, we need x squared minus 7x to be positive, and we can't even equal 0 because then we'll be dividing by 0. I'm going to go ahead and factor this. And it looks like my critical values, meaning the x values that make the whole thing equal 0, is going to be 0 and 7. And now I'm going to need to refocus a little better. All right, so now we're going to do a number line. So we have 0, we have 7. We're going to split this into 3 regions. And I'm going to test a value of x within each of these regions. And I'm looking to see, when I plug those values of x into here, is this product becoming a negative or a positive product? So let's try x equals negative 1. Notice that gave me a positive 8. That means every x value that is less than 0 is going to result in a positive product. Let's try one in between. Let's do positive 1. That means that every x value between 0 and 7 is going to make this product negative. And after 7, that means every x value bigger than 7 is going to make this product positive. Now we need which x values are going to make this positive, and that's going to be our domain in interval notation. And you'll notice we have from negative infinity to 0, then we skip over to 7 and continue on. Now we are not going to include the endpoints in this case because when these equal 0, that'll make this denominator 0, and we can't have that. So our domain is negative infinity to 0, union, or, and then 7 and on to infinity. So 7 to infinity and negative infinity to 0. That is our domain. All right, let's continue on. Number 7. This is what we call a piecewise function, meaning depending on which domain value you're on, you may have, in this case, 2 different functions, but higher up you could have even more than 2. So let's evaluate f of -1 or -8, pardon me. So which one do I put it in? Well, 8 is negative and less than 0 is this top function. That means the -8 goes in the top function only. So f of -8 is -4. F of 0 gets a little tricky. You'll notice 0 is included in the bottom one, not the top one. That means I'm going to go 1 minus 0, or just 1. And f of 9. Now 9 is positive, it's bigger than 0, so that's going to go here. And then they want us to find the graph. I'm going to actually just graph it. I think it'll be a little bit easier. And for this one, when the x values are negative, I'm going to call this 4, call this 1. And this is -4. All right, so for this one here, these are only negative values, and I want to point out it is not included at x equals 0. So I need to have a clear open circle there. So that's this one here. The other one, and by the way, you see the slope is 1 over 1, right? So 4 over 4. Now this one has a negative slope, and it's going to cross at 1 as well. Now I'm going to make a big deal. This is a solid circle because we are including that point there. So here is our graph. Open circle here, closed circle there. All right. And here's the, I think actually this is the one that we just did. Number 8. Find the domain of the function and enter it using interval notation. All right. So for this one, put some papers underneath this. All right. We know that 7 minus t has to be bigger than or equal to 0. Notice we can equal 0 in this case because we can take the square root of 0. That's fine. We're not potentially dividing like that other one by 0. So I subtracted a 7 to both sides. Now, when I divide by the -1, remember when you divide, the inequality switches. T has to be less than or equal to 7. Also, 2 plus t has to be positive as well. Subtract a 2, I get t is bigger than or equal to -2. Now, I want to point out on the number line what this means. We have to make both true. So here's -2, and here's 7. And we're going to be very inclusive in this. So this means we're going to have a solid dot here, a solid dot here. So t can be anything between -2 and 7, including the endpoints -2 and 7. So the domain is right there. So t can be any of these values, but can't be anything outside of that. All right. Number 9. Another domain. And again, we can't let it equal 0. So this is going to be 49 minus x squared. Has to be strictly larger than 0. It cannot equal 0. You may notice this as a difference of squares. And we're going to have to do our number line again. Our critical values in this case are plus or minus 7. And I want a little bit more space, so I'm going to use the blank back. So our critical values in this case . So let's set up our number line again. So we're going to get -7 and 7. And again, we're going to partition this off and test a value in between each and plug them into here. So let's start here. We'll start with x equals -8. That is going to be 15. That's going to be a -1. That means any x value that I get there is going to be, any x value less than -7 is going to make this negative. Let's try something in between. I was like 0. Right, when that's 0 and that's 0. Meaning there's our positives. So we'll do 7 minus 8. 7 plus 8. Now, you might start thinking to yourself, the previous one we did was it just alternated. So maybe if I just find the first one, then I can just fill in the rest of them. Unfortunately, it doesn't work that way. Sometimes that happens and sometimes it doesn't. So you have to test each individual placeholder there. Okay, once again, we're looking for where we are positive. We're positive between -7 and 7. So let's put our answer down. So our domain is there. Number 10. We have, and I'm going to obviously need more space for this one, we have what are called composite functions. So I'm going to take f of x equals 7x minus 6, g of x equals sine x, and h of x equals x squared. And what we're going to do is we're going to find f composite g composite h of x. Okay, usually we just do 2 of them, but we're doing 3 today. What this means is this is f of g of h of x. Let's starting in the middle on the inside. I'm going to replace h of x with the function x squared. Which means I'm going to go to function g, and wherever I see an x, I'm going to replace with an x squared. And now what this means is that I'm going to take the function f, and where that x is there, I'm going to replace it with sine of x squared. And there it is. All right. And we are to the last problem of the day. So we're going to express this in the form of f composite g, and we're going to identify the functions for f and g. So I'm going to notice that we have u of t is the square root of tangent. So I have two functions here. I have the square root and I have a trig function, a tangent. So I'm going to say that f of t is root t. G of t is going to be the tangent of t. And the reason I am doing this is because if I do f composite g of t, this means this, which is f of the tangent of t, which means I'm going to take that t and replace it with the tangent of t. And you can see that's where we started. I hope you found this video helpful.